Today we're going to be talking about acid precipitation, or as we would know, or formerly known as acid rain. So this is Science 9 students studying environmental chemistry. You'll find this in topic 3 in your textbook if you want to reference this information for study purposes. We're going to be dealing with two outcomes, somewhat here, general outcomes. The first one is I can explain the effect of acids and bases combining together and also their effects on other substances. And I can describe the effects that acids and bases have on living things. So we'll mainly focus on the second general outcome, but we do touch a little bit when we discuss a little bit of information about neutralization of acid rain. And we'll touch with that information, we'll touch with the first outcome. So acid precipitation, to understand what it is, it's acid rain. And so the formation of acid rain comes from three basically it's going to come from three gases. So it's going to come from sulfur, okay, right here, and we're going to say that is sulfur dioxide, so it's SO2, and it's in a gaseous state, okay. Then it's going to also come from nitrogen, so we're going to say nitrogen dioxide gas, so NO2, and then carbon oxides as well, so we'll just say carbon dioxide. Now remember, we have carbon dioxide, we emit carbon dioxide, sulfur dioxide, nitrogen dioxide into the environment, and this is going to form, or it's going to combine with H2O, or water vapor, in the air, and then it's going to form a precipitate and an acidic solution. So all three of these, okay, are going to be called natural oxides, and that'll be important to know. And so these natural oxides are going to combine, like I said, with water vapor, okay. And what happens, it's going to combine with this water vapor in the air, and what's going to result is it's going to result in these water droplets that are acidic. And so if we take a look, if sulfur dioxide gas reacts with water vapor in the air, it's going to produce sulfurous acid. And so that's H2SO3. Now remember, acids have an excess of hydrogen ions. So that's this H plus right here. Okay. And remember, to neutralize it, we're going to have to add, we can add a base, and that'll form water and neutralize the solution. So the second acid precipitation we're going to see is it would be from sulfur trioxide, and it combines again. All of these are going to combine with water vapor in the air, and it's going to form H2SO4, and they're in aqueous forms, which means it's in a solution with water. And so that's going to form our sulfuric acid. And then what we have is nitrous or nitric acid, and that is going to be nitrogen dioxide, and that nitrogen dioxide again is going to combine with hydrogen, or H2O, or water vapor in the air, and it's going to form HNO2 plus HNO3, okay, and so we're going to get a more acidic solution. And then again, we have carbon dioxide gas combining with with water vapor in the air, and we're going to get H2CO3, which is going to be known as carbonic acid, and that is probably the least of the acidic acid precipitations we're going to see. But what's going to happen here is as these gases are emitted, which means they're going to be released and they're going to move up in the atmosphere, they're going to combine with that water vapor, and that combination and that chemical reaction that occurs is going to form acid precipitation. Now, if we take a look over at this scale, it's going to be more acidic than rainwater, and rainwater is going to be at a pH of 5.6. So that's rainwater, and that's on average, but that's an average of the rainwater in our area. So it's going to be an average pH of 5.6. And so what happens is, if we take a look here, we're going to see this acid rain right in this region. So it's going to have a lower pH, therefore it's going to be more acidic. So the closer we get to 1 or 0 on the pH scale, the more acidic it becomes. So we're going to increase the acidity. So what's happening with acid rain is it's more acidic because of this chemical reaction and the combination of these natural oxides, so the sulfur dioxide, nitrogen dioxide, carbon dioxide, and sulfur trioxide. These are all going to create an acidic solution, and as it falls down to the earth in the form of precipitation, or what we know as, say, rain, sleet, snow, it's going to collect in lakes, ponds, water, and rivers, streams, and get in water bodies, and then from there it's going to harm aquatic life in those lakes, rivers, and streams and such, oceans, and then it's also going to, from that, it's going to harm every other every other organism that relies on that particular ecosystem or that particular water source. So these are some acid precipitations. Okay, so just remember, if you take a look here, it's in combination, but it has this hydrogen. Okay, pure water, remember, water is neutral. Okay, and if we can get pure water, then we can neutralize the solution. But notice that they have these combinations of these hydrogen ions, which come from right here. Okay, so again, this picture, we're seeing some emissions coming out of vehicles and such, off of buildings, and it moves up into the atmosphere, and we see this sulfur dioxide right here and this nitrogen dioxide here as well. And then when it forms with the water vapor and it comes down as precipitation, ends up in the water stream, and it'll affect the plant life and the aquatic life in that area and continue to cycle. As we know, the water cycle occurs. Well, that is going to affect species, and it's going to move again, affecting different species. And as a species is affected, it's going to affect other species along different trophic levels at an increased rate. So some of these effects of this acid precipitation, okay, as this acid precipitation hits the ground, okay, it's going, like I said, it's going to have a lower pH, which means it's more acidic than rainwater, which we would say is at 5.6. So right here we have rainwater again, and so as normal rain without these harmful acid precipitations falls, it's going to fall at a pH of 5.6. Where, remember, neutral is going to be at 7. Okay, so neutral, that's pure water as a neutral solution, or a neutral pH, but it's going to have a pH of 7 to be neutral. So 5.6, but when we get in that range of 3 to 4 as a pH on the scale, then what we're going to see here is we're going to see a more acidic solution. So some of the effects that we're going to see with this is it's going to one, get into the water and lakes, and it's going to affect aquatic life and kill organisms in those lakes and streams. But then also, as it falls, it's going to actually make its way into the soil, and it's going to create less fertile soil, and it's going to cause problems there with growth and such of other trees. It's also going to stunt tree growth, and if you just take a look at these two diagrams here, we'll see the difference in this tree in comparison to this one here, and we'll see that it's actually stunting the growth and it's causing some problems because, one, the soil is affected, but also it directly affects as the trees and plants try to take in the nutrients they need. But it leaches toxic chemicals from the soil, and it brings these toxic chemicals out of the soil onto the surface where they can be consumed by other organisms. And then it can also, like I said, damage these aquatic ecosystems, which is very harmful. And once we cause effects there and we can damage and destroy these aquatic ecosystems, then there's other organisms that rely on that aquatic ecosystem for survival. So now what we are doing is we're creating harmful effects as we move through the different trophic levels in a food web. So it's also going to corrode and exposed metal. So if you take a look right here, we have exposed metal, and it's actually going to corrode that. So when we talk about why structures fail, well, if we have metal that is exposed to the elements, then acid rain can actually corrode that, which is going to cause metal fatigue, which can cause these structures to fail. And some of these structures might be highly reliant, or some of the structures that these metals are holding up or are part of their design are going to be heavily reliant on their strength. And if they're fatigued and they're corroded, then we can see the collapse and we can see the fatigue and the failure of these structures. And then it breaks down stone and limestone. So if we had a statue or a structure as such right here, what's actually going to happen is you can see that it's been corroded and damaged. Well, and that is the cause of acid rain. It might be also the cause of other external forces being applied to it, such as wind and blowing sand particles and such, and sun and temperature. But acid rain has a lot to do with the breakdown of stone and limestone. So those are some of the harmful effects that we're going to see in our environment. It's going to get into the water supplies. It's going to reduce soil fertility, so it's going to affect the soil, and then when it does that, it's going to affect tree growth, plant growth. It can corrode metal surfaces and break down limestone and such. So it has many harmful effects, this acid precipitation, and we keep society in general, our ecological footprint, especially in North America, is quite poor. And so what's happening is we have many or way too many emissions, and what we're doing is we're emitting these harmful gases, and they are combining with the water vapor and forming these acid precipitations, thus harming our environment and our various ecosystems around the globe. And so reducing effects of acid rain, what's going to happen here is if we want to reduce, one thing we can do is we can treat lakes with lime, or also known as calcium hydroxide. And if we treat those lakes, okay, with this lime, what that's actually going to do is it's going to cause a neutralization reaction, okay? And then that neutralization reaction, this lime is going to cause the acidity to neutralize and form salt and water, therefore creating a less harmful solution. So if we add lime to lakes, then we can protect those ecosystems, and it's going to neutralize, and then that neutralization reaction is going to produce, okay, it's going to produce salt and water, and that's a reaction that occurs here. Okay, so that's one way that we can reduce the effects of acid rain, and we can treat the lakes and water bodies that we have as well. One thing to look out for that is a harmful effect, if you were to look in a lake, and in that lake, if you were to look in, the water was crystal clear, excuse me, sorry, the water was crystal clear and you could see down to the bottom and you didn't see much vegetation or plant life, it probably means that it is affected by acid rain because there's not many things living in it. An aquatic ecosystem typically has a lot of plant and vegetation life, and also a lot of various species living within it. So if it's clear and it doesn't look like there's a lot of activity in the water, it's probably affected by acid rain and its harmful effects. So anyways, that's acid precipitation. Hopefully that helps. If you have questions, please bring them to class, and don't forget to play, pause, rewind, watch the video. If you want, take notes. It's going to be beneficial for you as well. Anyways, thanks for tuning in, guys. We'll see you on the next one. Bye.